Soma.
Right. So this whole region along the outside of the cerebrum would be gray matter. And in that gray matter, I've got a bunch of neuronal soma. Okay? And they are sending their axons down, let's say, to the thalamus. I'm going to call that my thalamus. And these guys are coming in and synapsing on my thalamus. And in my thalamus, I also have neuronal soma, right? This is a nucleus of the brain. And so these guys are then going to send their axons down the brain in towards the spinal cord. So what I have is I've got my outer gray matter, right? What do we call all this region where I have axons? White matter, right? Now this is talking about the thalamus, but in addition to the thalamus, I also have regions of deep gray matter, right? So that would be my cerebral deep gray matter. Okay? So I've got some fibers here, and all of these fibers together are traveling kind of in a north-south direction. Does everybody see that? What would I call a tract that travels in kind of a vertical direction? You guys are making me very nervous. I have to start studying this weekend.
Projection.
Yes, there we go. Projection fibers, right? These guys are projecting down towards the spinal cord. If I had similar axons projecting up to those neurons, it would also be a projection type of fiber. Now, if I had axons from these pink guys traveling across the midbrain, or not across the midbrain, but across the midline, what would I call that type of tract? Not a projection fiber, but a commissural fiber, right? It crosses the midline. And if I had this guy talking over here to another neuron there, what would I call that? Associational. Very good. Okay, now, what I want you to do, I'm going to draw some guys over here. So I'm going to call this the left side of my brain and the right side of my brain. Okay, so this is going to be my left arm. This is going to be my left leg. Let's put a right and a right. Okay. I have neurons up here in my left primary motor cortex. Okay? Those guys are going to send their axons down the left side of the brain. When they get to the medulla, they're going to cross over to the right side of the central nervous system and now go into the right side of the spinal cord. Okay? What is this that I've drawn, this long line? What is that? It's an axon, right? So it's going to be traveling in a tract because we're in the central nervous system. Are we good so far? Right. This guy is going to come over, and let's say that this particular region is responsible for arm movement. Okay? So I'm in my left brain. I travel down the left side of my brain all the way until the medulla. What do we call that crossing point at the medulla? Does anybody remember? It's a weird one. It's called the motor decussation, right? Where those fibers decussate the midline, or when they cross the midline. This guy is going to come down, and he's going to synapse on a neuron in the ventral horn of the spinal cord in my cervical region. Now, it's in my cervical region because those are the neurons that make my brachial plexus, that give me the nerves that innervate my arm. He's going to synapse on a neuron. It's going to send its axon out to be part of a nerve. that nerve is going to travel to the arm, whichever muscle is being innervated, and it's going to synapse on that muscle. So we can see that although it's controlling the right arm, the actual neuron responsible for initiating that movement is in the left side of my brain. Okay? So motor function-wise, if I have a person and they come in with left arm paralysis, I can look in the nerve, right? I can look in the left side of my spinal cord, all the way up, I can follow those axons until I get to the medulla. And then I'm going to start looking on the right side of things, right? I'm going to look on the right medulla or the right pathway up to the primary motor cortex in the right hemisphere. Does that make sense? Good. So let's look at this image. If I have a person and they are displaying issues with their right arm, motor-wise, it could be a problem with the nerve on the same side, could be a problem with the spinal cord on the same side, or the tract before it reaches the medulla. Could be a problem on the left side here, could be somewhere here, could be all the way up in the cortex. So those are all the places I'm going to look clinically to try and identify where this problem is. Good? Now, sensory-wise, we see a very similar type of occurrence, but where that information crosses the midline is different. So I'm going to draw my sensory information in green. Now for sensory information, I'm going to go from the right leg, but it's going to be the same for the right arm, just a different location. I have a unipolar neuron. Part of that axon is acting as a dendrite, collecting information. That information is going to travel in towards my spinal cord, and then it's going to enter my spinal cord. Good so far? Right. This guy is going to synapse and then send its information immediately across to the other side of the spinal cord. So he doesn't wait to the medulla to send that information to the other side of the spinal cord. He comes in, he synapses on an interneuron, and then that guy sends his axon straight over to the other side. So when I look at sensory information, I'm going to see that if I have issues, let's say I can't feel my right leg, so not paralysis, but numbness, or even maybe pain, some kind of a sensory problem. It could be in the nerve on the same side, right? Could be spinal cord, same side. Could be spinal cord tract, opposite side, right? And from here, it could be any pathway along that way, all the way up to the primary somatosensory cortex. So again, right leg, left brain, left spinal cord. Does that make sense?